Hello, my name is Inês Azevedo. I'm a research assistant professor in the Department of Engineering and Public Policy, and I'm also the co-PI and executive director for the Climate and Energy Decision-Making Center. This is a large center anchored at Carnegie Mellon, but distributed across several universities and funded by NSF. Today I'll be talking about the prospects for energy efficiency in the United States. So if we start with the premise that we need to reduce substantially the amount of greenhouse gas emissions by roughly an order of magnitude, we'll need to start rethinking the way we produce, use, and transform energy in the United States. Well, if that is the case, then we need to start seriously thinking where we start. So what this flow diagram shows is the amount of CO2 emissions in the US economy by sector, by end use. And so what you can see in the first instance is that most of the CO2 are related to energy, but also that there is a substantial part of CO2 emissions that are related to residential buildings and commercial buildings. So there is an opportunity to, with new technologies, reduce the emissions, perhaps in a cost-effectively way. So the US is doing already quite a bit in terms of energy efficiency policies. So currently in the United States, energy efficiency is in fact perceived by many as one of the key climate change strategies, and energy efficiency resource standards are already underway in several states. What are energy efficiency resource standards? Well, it is a mandated goal to reduce energy consumption by a certain amount and by a certain date. As you can see in the map, several states have those goals. Sometimes those are mandated goals, in other cases not. Some include both electricity and natural gas, others include only electricity. There are also quite large investments in energy efficiency that are done at different levels, both federal and state. For example, the spending by electric utilities in the United States is roughly $4.5 billion per year. At the same time, with the American Recovery and Reinvestment Act of 2009, a substantial portion of money was allocated for energy efficiency programs, $11 billion. And Pennsylvania, for example, was awarded $0.5 billion. So how much are we getting out of those investments? Well, that's what me and several of my colleagues have spent a substantial amount of time trying to define. How much CO2 can we actually reduce by pursuing energy efficiency strategies? So we've done so by creating a model that looks at the different residential energy end uses in the different regions of the United States and tries to determine for different policy goals, whether it is to reduce CO2 emissions, reduce electricity consumption, or primary or final energy, what is the best allocation of technologies that should be pursued. So what you see in the figure is on the y-axis, the cost of effectiveness of different interventions, and on the x-axis, the amount of CO2 emissions that can be avoided through those interventions. So every little point in that curve corresponds to, for example, switching from incandescent to fluorescent lamps in the northeastern region. So now, the green area that is below zero corresponds to actually things that will save money to consumers and that are cost effective. The red area corresponds to things where consumers would need to spend money to reduce CO2 emissions. So in a nutshell, what we found is that we could achieve 30% of emissions reductions in the residential sector in the United States in a way that would actually save money to consumers. Now, there are several factors, some related to markets, some related to behavior, that prevent this potential from being achieved. So what are those factors? What is their importance in terms of choices and behavior to move towards a more sustainable energy system? Well, that's what we've been working on too. So in several studies, looking at how people choose and use technologies, we've been able to detect and identify what are those key factors, namely price and the disconnect between the way people perceive technological attributes and those actual technological attributes. We've been doing several studies for that in the case of lighting, exposing folks to different lighting conditions with different brightness, different color, and trying to identify what are the technologies that are preferred and the conditions that are preferred by consumers. I'm not going to present the results from that work today, but from a related work, which is the following. If people invest in energy efficiency and in energy efficient devices, then if those are cost effective, you'll save money over the lifetime of that investment. Think about the case of switching from incandescent lamps to fluorescent lamps. You're saving money over the lifetime of the technology. Then the question arises, what do you do with those savings? Well, if what you do with those savings is leaving the lights on for longer periods of time, that's called the direct rebound effect. If what you do is basically you take the money that you saved with that investment and spend it to travel abroad, that's called the indirect rebound effect. So in work with one of my PhD students, Brenda Thomas, and with colleagues from Carnegie Mellon, we're trying to understand what's the magnitude of that effect. There is a huge uncertainty whether those rebound effects actually matter or not. Some argue that those effects are so small that they can be neglected. Others argue that they are so large that they can actually backfire. This means that energy consumption and CO2 emissions could actually increase as a result of energy efficiency policies rather than decrease. So we've looked at the case of energy efficiency induces in the residential sector that are powered either by electricity, natural gas, or gasoline, and tried to understand what the estimates for those effects would be. So we start by using a model that was developed here at Carnegie Mellon to assess what will be the supply chain effects in terms of carbon footprints of US households. Here I show the results for an average US household, and basically showing in each one of those stacks not only the site emissions from the household activities, but also the indirect ones. So the gasoline emissions are not only the emissions from driving, but also to build your car and etc. So the scenario that we're trying to look at is when you pursue an energy efficiency strategy that reduces gasoline consumption, as it is shown in the figure, how much of that is going to be used to drive more, and how much of this is going to be allocated to other end users. So by using income and price elasticities and a series of different scenarios for different income levels, what we found is that in fact, there is no evidence of backfire. So the emissions are always reduced and the energy consumption is always reduced after those interventions. It is also the case that the rebound effects, both the direct and indirect, are not overwhelming. They are always less than 30%. However, they are large enough that they should be considered in policy analysis and in projections of future energy demand. So with this I'll end. Thank you so much for your attention.